everyone. The next section, we have Caleb Browns talk about the perfect setup, and it is not the setup.py. Thank you so much, Caleb.
Thank you very much. Hello, thank you. All right. So you heard my name. I'm Caleb. I'm a software engineer at Google. I too work with Nikki, and I work on open source security and also deps.dev, which hopefully you were here for the last session on that. I also maintain the OpenSSF malicious packages repository. So I have an interest in Python security, and as part of my work, I get to look at malicious Python packages. And kind of because of that, I'm going to talk about the definitely not controversial topic of Python packaging and how to do it the right way, or what I think is the right way at least. So this presentation is split into about 4 parts. I have hot takes, history, how-tos, and hacks. Hopefully this covers various skill levels and your interests. So let's dive right into hot takes. Here's a hot take. I hate setup.py. I'm not a fan. This opinion has been formed after looking through copious amounts of Python malware. So today I'll tell you why I don't like setup.py, and I'll hopefully convince you, if you're not already, to use something else. But before I tell you why I hate setup.py, I need to explain what is setup.py. Now, I'm sure you're aware, setup.py helps answer an important question: how do we share stuff? How do we get things from where it's developed to where it's used? All open source ecosystems have to solve this problem to work efficiently. So Node has things like NPM, Ruby has Ruby gems, and generally the process for how this works for each ecosystem is roughly the same. A developer writes and hopefully tests their code. They package it into an artifact they can share. It gets delivered, usually by uploading to a central repo and downloading again. And finally, it's installed on a system for use. Now, in Python, packaging usually involves building. And it might be either a source dist, sdist, which doesn't do much except kind of put the files together into an archive. Or it might be a binary dist. They're called wheels, where any native extensions get precompiled, and the archive is structured in a way that makes it really fast to install. And delivery is usually through the pypy, I don't know how you say it properly. I'm sure this is a religious battle somewhere. And finally, it gets installed via pip or UV or something else, and that will usually resolve and install dependencies as needed. Now, setup.py is kind of focused on these 2 parts. And as part of that, it takes care of metadata. What's the name of the package? What version is it? Who wrote it? Those sorts of questions. It also specifies dependencies. What else do I need to install to make this work? It also has responsible for building the actual artifacts. And it can also sometimes play a part in its installation. So if that's what setup.py is, why do I hate setup.py? Now, the extension might be a giveaway. It's just code. It's Python. That means everything it does requires code exec. Setup.py can do anything it wants because it's just code. Now, here's a simple example of setup.py. Imports setup tools or dist utils if it's old, and it must call the setup function to really work. But what does it look like if we take this to the extreme? Here is an example of a package taking care of its own dependencies. You can see here that it's iterating over the requirements file and installing each one by one. The favorite part about this for me is that you could have just passed the requirements file with the -r argument and installed them all at once. Here's another example. Here it's checking to see if R is installed, and if it's not, it'll try and install it. And when it does this, we can see that it's changing the system. And what's particularly bad about this example is it's adding a new registry and adding a new key to pull debs from that registry, which means this system is now trusting something that the installer of this package may not have wanted at all. And in this case, and the previous, how do you even uninstall these packages cleanly? All right, here's one that's more fun. It's downloading a video from YouTube. It's then playing it in the terminal and rickrolling the installer. That one's kind of fun. But not all setup.py files are this friendly. Here is a malicious package identified earlier this year. It doesn't appear to be doing anything wrong here. It looks like some dead code. Let's turn word wrapping on our editor. Oh, there it is. It's all obfuscated code hiding on a single line. And if we deobfuscate it, we see that it's attacking Windows users. You can't quite see in this because the lines are really long. But it's downloading an exe file, and it's running it. And many malicious packages take advantage of setup.py. So I hate setup.py mostly because it has code exec, but it also has other issues as well. It doesn't have any structure. All it has to do at some point is just call setup. Otherwise, any Python code can be in there and do anything. And this lack of structure eventually means that it's really hard to change it. Only humans can really write it, and even then, depends on how kind the person who wrote the setup.py was in the first place. And sure, a Python interpreter can read it, but that's about all you can reliably do across all the setup.py files. And finally, you're kind of locked in to using setup tools. It only works, setup.py only works because setup tools is already installed. And if you want to use something else in your build process, most of the time you have to ask nicely in your docs or add some hack. So if not setup.py, then what? What alternatives are there? Or what is the alternative? And I'm going to sell you on pyproject.toml. I think if you're not using this today, you should be using it. And for those who aren't familiar, this is what it looks like. There's a build system spec and some project metadata. And we'll cover some of these features a bit later in more detail. But some of you might look at this, you might know something about packaging and go, oh, it looks a bit like setup.cfg. What about that? Doesn't it have the same features as well? Well, maybe to understand why we're using pyproject.toml and not setup.cfg, this is a tongue twister, it's worth looking at some history. This is a highly abridged history. There's a lot more detail, and I'm sorry if I get anything wrong. But it all starts in the year 2000, when distutils was added to Python. And believe it or not, in 2000, setup.cfg was present with setup.py as a supported way of specifying things. But at this time, setup.cfg was really about overriding arguments to setup so that people could make it work on their machines when it's running. Let's fast forward 10 years later, and an effort was started to create distutils 2. And its big idea was something called declarative config, where you specify what you want installed or what you want to do rather than how. And they stuck it in setup.cfg, not in Python code. But unfortunately, distutils 2 was abandoned just a couple of years later. Time passes, but the declarative config dream continues to live on. A tool like D221, even PBR continue to support this idea. But also at this time as well, other tools like pep8 start putting their config inside setup.cfg. It feels like maybe they should be using setup.cfg. In 2015, though, a project called Flit came along. And it had some new ideas. It doesn't use distutils or setup tools at the time. Well, it doesn't even more. It was created specifically to just build and upload wheel files to Pypy. And it also included its own declarative config, pypy.ini. So this idea of not depending on distutils or setup tools was new. So in 2016, or roughly around then, a new spec emerges. I'm going to mention PEPs. I'm not going to read them out to you because they're long and specky. So PEP 517 comes along, and it specifies something called build backends. So there's no more lock-in for setup tools. You can use whatever you want to produce the archives. But I'll tell you more about what a build backend is. Build backends are focused on producing the artifacts for distribution. So the SDists and the wheels. They have super simple API. You just have to specify those two functions, and you can build a build backend yourself, just as long as it makes the artifacts that you want. And where there are backends, there are usually front ends. And so a backend is called by the build front end, like build or pip to make use of the artifacts like installing or uploading. So that's what build backends are, and that's what PEP 5.17 introduced. But how do you actually say which one you want to use as a project? And that's where its sister PEP comes in, 5.18, where it defines pyproject.toml using a declarative config spec. But at this time, it only includes the build system and tool sections. The tool sections are there so tools can safely extend and use that file for storing their own config. So why did they create a new standard and not setup.cfg? Well, it turns out setup.cfg had some problems. It didn't have a schema. People kind of just used it however they saw fit. Config parser, turns out, had some problems that made it less suitable. Between Python 2 and Python 3, it behaved slightly differently. It also only has strings as the type of value that it exports. Also, if you're going to make it a standard, you still have to keep the old versions working with distro tools and setup tools. So how do you make that work as well? And then finally, it had been in use for 20 years. How do you, well, at that time, 16 years. How do you deal with all of these packages that already exist and making that work? So pyproject.toml was the one that was chosen. But 2016 is not over. Around this time as well, making use of PEP 5.17, setup tools adds declarative config and metadata in setup.cfg, which seems a bit ironic. But after this, new build backends start to emerge because they can exist. Things like Hatch and Poetry. And at this stage, declarative metadata, things like the name and version, aren't included in the spec. So build backends kind of do their own thing. Each backend adds their own stuff. So in 2020, the problem was solved with another PEP, PEP 6.21, where common metadata in pyproject.toml is included. And this means that build backends don't have to do it themselves. They can all share the same set of metadata. And that makes it easier for you to pick which backend you want to use for doing your building. So what about setup.cfg? That's a question at the start. It was a thing. It's not recommended to be used anymore. You should be using pyproject.toml. Now, this is the year 2024. It's been 4 years since the last of those PEPs and 8 since the first. No, everyone has migrated, surely. Let's look at some graphs that show adoption. Here are the raw numbers that I produced. These are pure Python packages, and the blurple line is no setup.py, so there's no setup.py file, and the yellow line is the packages with setup.py. And you can see there's promising news. The line without setup.py is slightly higher. And if we turn it into a proportional graph, where green is no setup.py, we can see that the trend is up and to the right slightly. And we passed the 50% threshold around the middle of this year. And if we break it down further and we look at the 3 files I've been talking about and which set of ones are included in each package, we can see an interesting trend here. That packages that only include pyproject.toml are well on the way to becoming the majority. And all the others, including ones that have pyproject.toml and setup.cfg, are on their way down. This is excellent news. So how do you join this trend? This is where we move into how-tos. Let's look at some of the way you can use pyproject.toml to do what you might have used to do in setup.py. First of all, if you're a minimalist, this is all you need to publish a package using pyproject.toml. Name and version are the only 2 things required. What about build backend? So this is setup tools if you wanted to use it as a build backend. This is, except maybe for the version number, this is the default if you don't specify it at all. And if you're ready for a change after 2 decades of using setup tools, maybe you want to try Flitcore. Flitcore is part of the Flit project, and this is designed for pure Python packages. And you can see there that the build backend points to the API that builds the artifacts. What about build time dependencies? Now, setup.py has a problem if dependencies are needed to actually run setup.py. Either you easily ask nicely in the docs for somebody to install something like Python here, or you do something like this abomination inside your setup.py file where you do it yourself. But with pyproject.toml, you only need to add it as a requires in the build system. And it will do it before you, before the build front end like pip or build tries to call the build backend. What about other dependencies? It's pretty straightforward. Here's a list of the dependencies. Includes all the stuff like optional extras, version requirements, and environment markers. You can even do optional dependencies. Now, I should mention here, like if you're developing an application, you may still want a requirements file because you can do pinning of your versions in them, at least until PEP 751 becomes a thing. All right, what about readmes and licenses? Usually, there's some code at the top that opens the file and tries to load it in so it can put it in the long description. In pyproject.toml, it's really easy. You just point it at the file. The top one will automatically detect the content type from the extension, and the bottom one will use it explicitly from the type there. Licenses is easier. You can point it at a file, but you can also just give the name of the license. And even better, use a classifier to point to a well-known one as well. Now, a common pattern as well in setup.py is to read the version from a file. Now, pyproject.toml supports this idea through the dynamic array. And the dynamic field tells the backend, hey, I don't know anything about this. Can you tell me about what this is? And so the backend will populate the field. And so most backends either support the ability to read the version from an attribute in a Python file, the file itself, or even through the source code management, like through Git tags. So here is flit again with dynamic version, and flit is opinionated. This is all you need to add to your pyproject.toml file, because in your module, in the init file, or if it's just mypackage.py, you can just specify dunder version with the version number, and the ast.literaleval will read it in, and you get your version. You can also use something like setup-tools-scm as in your build system requires, and this will automatically pull the version from your source code management. You can even do native extensions in pyproject.toml. Here is a list of backends that have declarative support for build backends, for C extensions, for CPython. If they're particularly complicated, you might have to write Python code, but for the most part, you do have options which don't require that. And here's an example using setup tools, using their ext modules table. So that will build foo.c into that library there. So let's compare the two. I've added declarative no there to setup.py, and pyproject.toml is specifically declarative. It's about what you want to do rather than how. And yes, because it's human readable and machine readable, you can write code to manipulate pyproject.toml. Machines can be used to migrate or do things like that, and it's human editable. It has a specified structure. It's not just something that evolved over time. You can use anything to build, and it, unlike setup.py, let's talk about this. This is the fourth section of my talk, hacks. I'm sorry to say, but pyproject.toml also has code exec. Can't avoid it. So to show you how to do this, let's go through my tier list of malicious code exec in pyproject.toml. It's time to think like a hacker. Please don't get any ideas and publish bad things to Pypy. So let's start at the bottom in the C tier. We're going to use a pyproject.toml backend of setup tools. And I'm just going to have a setup.py file. And this works. It will execute this code. Now, this is useful, perhaps, if you've got really complicated build requirements. But you can still drop malware in there if you were going to be bad. So setup.py isn't eliminated by setup tools as a thing. But you could use a different backend and it wouldn't run it. All right, let's move to the B tier. These are getting slightly more malicious. We've got code exec via hooks. This is using a build backend called Hatchling. It's part of the Hatch project. And you can see there it defines a table called hooks custom, and it's empty. It doesn't look like it's doing anything untowards. But actually, if you put that in your pyproject.toml, it will execute a file called hatch_build, and it will execute the code that's in there. Again, this is used like setup.py to build your dependencies, if they build your package if it needs more complex build rules. But an attacker could make use of this as well if they wanted to. And you may have been looking at that build backend going, couldn't that just be like a thing I want to change as well? So you could build your own build backend that does naughty stuff, and like you could specify the API just by importing setup tools' API, and then do your code exec after that. So that's my B list of code exec via pyproject.toml. And here's my A tier. This is getting more malicious and harder to spot. Where's my? So this uses the dynamic attribute fields for code exec. So here I'm using setup tools for populating my version field. And the way setup tools does it is you specify in a special table this version field that points to this version attribute in my package. If we look at this, is that being parsed by ast.literaleval? No, it's an F string. So it can't be parsed by literaleval. It has to be executed. Now, it's worth understanding a bit about how dynamic attributes work across at least flit and setup tools, because they're kind of build backend dependent. The build backend defines how this behavior works. And for at least setup tools and flit, they'll first try and parse ast literaleval. But if that doesn't work, guess what it does? It just executes the module. So let's take this to the S level. This is my S tier 1. This is me being as most hackerish as I can. This is the same pyproject.toml as before, pointing at basically the same version. And here is my code. This will execute the code at the bottom. But can you figure out why? This is code exec via homoglyph. And that API import at the top looks kind of boring, but it's the thing that makes it work by actually specifying the version. So in terms of code exec, pyproject.toml is kind of worse, actually, because each backend has its own set of vectors for code exec, whereas setup tools only has setup.py. But it's not worth writing pyproject.toml off at this point, because we went through this list here. Pyproject.toml is still better than setup.py. And even then, the code exec at the bottom is not is optional. It's not something that's guaranteed to happen. Not only that, but being declarative means we have new possibilities. We can allow list our build backends, perhaps. We can vet them to figure out which ones are safe or unsafe. And for each backend, you might be able to enumerate the different way code exec could happen. So pyproject.toml is still better than setup.py, even though code exec is still arguably a problem. So now, hopefully, I've made the case for pyproject.toml. What should you do? Actually, there's 5 sections to this talk. This one's homework. We're nearly at lunch. Firstly, if you're not already, please use pyproject.toml. And if you're using it already, have a cookie. If you make the switch, you should have a cookie too, but you're going to have to find them yourself because I don't actually have any. There are lots of examples on GitHub as well of people making this switch. I was digging through this code search, and there's lots of cases where this happens. This is just for the text migrate setup.py pyproject.toml, and then changing it to commits. And there's heaps of projects there. If you deleted the setup.py, you might get more. And I've got some PRs that I dug through to find where Django had gone through this, as well as Flask. Also, you might find that you've just used the default build backend. Maybe there's one that better suits your needs. Maybe you have native code that could be better suited by using a declarative config in a build backend that's better suited to it. And lastly, stay safe. If you've been to the last 3 talks, hopefully you've got the point. Check your dependencies, know what you're installing. Go take a look at deps.dev and explore what you're actually pulling in. Even better, go and set up automated tools. There's a little bit of an upfront cost and some small maintenance work that goes on, but you can take advantage of tools that are automatic for keeping things up to date, for telling you when there are security vulnerabilities and issues in your packages. Also, have a healthy suspicion of all the artifacts. I've got a link there to a bug I found in pip where I was able to get code exec on install with a wheel file. So have a healthy suspicion. You don't have to be like ultra paranoid, but just beware that you're pulling in code that other people have created. So the perfect setup. It's not setup.py. It's not setup.cfg. Is it pyproject.toml? Well, actually, I don't think it exists. At least not yet anyway. But pyproject.toml is much closer. Cool. Yeah, that's my talk. Thanks.
Thank you, Caleb. Here's the amazing speaker.
Thank you.
Any questions? Do you want to take a question or two?
I'm happy to take a couple of questions. I think we've got 3 minutes, if my time is correct. It's always the person furthest away.
Thanks for that. That was great. You sort of hinted towards the end there about vulnerabilities at install time versus build time. I was wondering how many of the hacks you mentioned are vulnerable to install time versus build time vulnerabilities.
So, yeah, that's a good question. It depends on what you're pulling. This is where it's complicated because Python and PyPy allows you to have like source distributions and binary distributions. So binary distributions normally just unzipped into wherever they need to go, which theoretically shouldn't run code on install, aside from the bug that I found in pip. So you should be unlikely to get code exec in that case on install. But if you're downloading the source distribution and you have to build it, it's no difference between on build and on install because both are going to happen on your machine. And the attacker isn't, like if they're the one publishing the package, they're somewhat in control of both of those. Yeah. But normally wheels are safer, but you can do a lot of mischief with wheels as well, like PTH files, and you don't even know what's inside the binaries. So.
Thanks for the talk. I'm sure many people have Googled Python packaging tutorial and have been overwhelmed by the so many different strategies that there are. Do you have any favorite pieces of documentation that you'd recommend?
Yes. Go to the Python packaging documentation. Most of that points to the right thing. And it will probably be updated if it's not. Like I did a dig around and I didn't include a slide on it, but I was finding roughly about 50-50 in terms of people pointing to pyproject.toml versus setup.py. So like it kind of bears out in the numbers in the graphs that is kind of representative of not just the packages, but the documentation as well. So blog posts are being updated and things like that. But go to the Python docs. I should have probably linked them as well, but yeah, if you search for Python packaging, I think there's a URL. It's like packaging.python.org/something or other. That's the best reference for it, yeah. Excellent. Enjoy your lunch.
Thank you, Caleb.
And
we are going to have lunch now, and we will be back at 1:30. and enjoy. And thanks again, Caleb and all the morning speaker.